Hi, this is Mr. Manley. In this video, we're going to look at a pretty inefficient way to solve this system of equations. We have a few ways to solve this system already, probably. You have substitution, elimination. Maybe you could think about doing it graphically. Maybe you know how to use a graphing utility to solve it. Here we're going to look at using matrices to solve this. And really, the main reason that we're doing this is to show a matrix application and understand that matrices have many wide and varied applications. And this is just a beginner's introduction and something to show you how matrices can be used. And there are more other applications, more complex beyond the scope of our work here, that are available. But this is just to show you an application. And even more specifically, it's to show you an application of using the inverse. So this says, you can see here, it says find the inverse to solve the system. So that's what we're going to do here. I'm going to begin by taking and setting up what would be called a coefficient matrix. That's just using the coefficients from the equations that are in the system. And then I'm going to give myself a variable matrix, x and y, and I'm going to give myself a solution matrix, 4 and -6. So I think that's pretty self-evident if you just stop and look at where those matrices come from, or look at the system that I was given, and you can understand where these matrices come from. Now from here, what I would like to do is solve for x and y. I want to solve here. I want to know what's x and what's y. Thinking algebraically, I would want to isolate these, right? And wanting to isolate these, I would want to divide by this matrix. So if I could divide by that matrix, and that cancels out, and then I could divide this matrix by that matrix, I would have x and y isolated. But as you know from a previous video, there is no matrix division. I cannot divide by a matrix. But what we do have is the inverse of a matrix. So the first thing I'm going to do is find the inverse of this matrix here. And I'm going to call this, we'll call it matrix A, I suppose. And I'm going to go down here and say this is the inverse of that matrix A up above. And that is going to be following a formula, which you should have in your notes from a previous lesson. I'm going to go 1 over 2 times -8 minus 7 times -2. And then the matrix that I get using the method of inverse is switching those two numbers and doing the opposite of the other two numbers. And that's just following the formula. All right, so what do I have with the first factor? This is 16, looks like it's 16 plus, -16 plus 14. So that's going to be -1/2, right? So this all here is going to come out to -1/2. And I'm going to multiply that by this matrix, or I'm going to multiply that or distribute that to this matrix. So it's -16 plus 14, -2. So -1/2 times all of these, and I get -1/2 times -8 is 4, -1/2 times -7 is 7/2, -1/2 times 2 is -1, -1/2 times 2 is -1, and there we go. That's the inverse. Now I'm going to take that inverse and I'm going to use it instead of division, which there is no such thing as matrix division. I'm going to put that up here like so. So there's the inverse. I'm going to multiply that to the left side. And I'm allowed to do that as long as I multiply it to the right side. And know that when I set this up on the right side, I need to put it in this precise position. And I'll look at why that is in a moment here. So I need to put the matrix here, put the 2 by 2 matrix here, so that when I multiply it by the 2 by 1, I'm going to be able to do that because these numbers will match. If I do it in the other order, and I'm not going to rewrite the whole thing, but if I just look at the dimensions, if I did it so that the 2 by 1 matrix came first, so if the 2 by 1 matrix came first and the 2 by 2 came second, then yeah, you see those don't match. I wouldn't be able to multiply them. So we definitely want to insert the inverse matrix in front of that matrix, and then we can multiply them. Okay, so first things first here, on the left, this matrix times this matrix, you could know from a previous video that a matrix times its inverse is equivalent to what is called the identity matrix. And we could work that out, and I could say I've got 8 8 plus 7/2 times -1, so that's going to be 8 minus 7 is 1. And then I'm going to have, that'll be 28, 4 times 7, and then minus 28 is 0. And then I'll have -2 and plus 2 is 0, and -7 plus 8 is 1. And there's the identity matrix. XY comes down. And then over here on the right, I'll multiply these two matrices. Matrix multiplication, something we're expected to have some mastery of by now. So what am I going to have? I'm going to have 16 and then minus 21. So that would be a minus 5. If you don't follow what I did there, you need to review your matrix multiplication. And then I'm going to have -4 plus 6. And that'll be 2. Alright, also from a previous video, we have that an identity matrix times a matrix is just going to yield that matrix. Just like 1 times 5 is equal to 5, an identity matrix times another matrix just yields that matrix. So the result on the left side is simply this. And on the right side, I've got that. And what do you think? This has got to be a 1-for-1 match, right? If that's x, then that's x. So x is equal to 5. I'm going to put that as a -5. X is equal to -5. And then this value, y, has to match that. So that has to be y. So y is equal to 2. And there we have the solution to the system. So, you know, if you're working with me in my class and you're working on ALEKS, I don't know how ALEKS asked the question, and maybe you could solve the system and get that answer without using inverse, but it will probably ask you for the inverse. What inverse matrix are you using to solve the system? So you'll at least have to go that far. And of course, for any written work, you would be able to need to be able to show this process and show that you know how to use the inverse to solve a system like this.